Hi students, we're going to discuss about decoder. What is a decoder? What are the applications of decoder? How we can realize the Boolean equation by using decoder? And then we're going to discuss about encoder. What are the problem is encountered in encoder? And then how to overcome of the encoder? Then some of the application in encoder with some of the examples. So these are the things we're going to discussing in this module. Let me see that the definition of a decoder. Digital information represented in some binary form must be converted into some alternate binary form. That means that it converts one form of coded input into another form of coded output. So what is a combination of a decoder? So there is an n input, so we should have a 2 power n outputs, so that is the line decoder. So here only one of 2 power n output lines responds with the logic 1 to a given input combination of values on its n input line. So that means that we have an n input combinations with n input combinations. So in that we have the 2 power n outputs lines, that will be only one line will be responded as a logic 1 when your outputs of a decoder is active high. Remember, your output of a decoder is active high. So then only it responds to the logic 1, so that output of the decoder I call it as a min terms. When your decoder output is active high. So let me have the block diagram and its functional diagram, or we call it as a logic diagram, and how this will be works with the truth table. Let me discuss with the 3 to 8 decoder. So remember, we have the 3 inputs and 8 outputs. Always the output start from 0 in the decoder. That should be remember. So here in 3 to 8 decoder, I am considering here is active high output. So in this case, I am getting as the output as min terms. So here in 3 to 8 decoder, we have the 3 input of combinations from 0 0 to 1 1 1 1. So that is 0 to 7. Whenever the input as encountered into the decoder, corresponding one of the output will be responded as logic 1. So for 0 0 0, the Z0 as responded as 1, that is coded into another form, and 001 Z1 and 2 Z2. For 3 it is Z3. Like that, it is all the input combination, it will be converted into another form of coded outputs. So this will be represented in the equation. Let me say that Z0, how I can write with the Z0 as Z0 is equal to X0 bar, X1 bar and X2 bar. That is what we represented here. That is the totally the min term is M0. Similarly, for Z1 I can represent it in as a 1 as in the binary form. That is what we call it as a 8421 code. So it is 8421 code. So in this case, X2 bar, X1 bar and X0. So this is will be represented as M1. Likewise, for M0, M1, M2, M3, M4, M5, M6 and M7, all the 7 output I can represent it in the form of X0, X1 and X2. I can realize in the logic diagram. So the operation, as we understand that, we given the input combination and it is decoded into any one of the 2 power n output lines. So that the input combination can be regarded as a binary number with the consequences that the jth output lines is logic 1 for j is equal to 0 to 7 only when input combination j is applied. It means that your input, let's say I given as x2, x1 and x0, I converted in the binary form. Let's say if you are going to making as 0 0 0, the decimal number this is 0, then your output z0, that is z0, it will be decoded. For example, if I am taken as a 5, that is 101, so your output of z5 is decoded. This is how the decoder works. We'll see the other types of decoder. Function specific decoder with less than 2 power n output exits. Example, decoder with 4 input and 10 outputs in which a single responding output line correspond to a combination of 8421 code. So this is we also called as a binary decimal decoder. Also we call it as BCD decoder. It decoded the BCD number from 0 to 9. So that's what we have, the 4 inputs, it works with 8421 code, and we have the 10 outputs from 0 to 9 output lines. So here we have the IC 74147. This is one of the decoder. It will be BCD decoder. So example, 4 input 7 output decoder that accepts a 4-bit of 8421 code and used to drive a 7-segment display. This also we can use for 7-segment display. So this is what we call as an octal decoder. So we have the 0 to 7. So totally we have 8 segment. Let's say this is your 7-segment display, so that whatever all we have the 7 with the dot, it will be decoded to, this will be used for displaying the 7-segment. Now we'll see some of the designing of logic system, how we can design by using a decoder. So as we know that we have an n input to 2 power n line decoder is a min-term generator. It means that outputs are min-term. It means that it is an active high output. So that's what we call as a min-term generator. So in this case we are using OR gates in conjunction with an n to 2 power n line decoder. Realization of Boolean functions are possible. So let me see that do not corresponds to minimal sum of products are simple to produce a particularly convenient when several functions of same variable have to realize. So I am going to be using 3 to 8 decoder to realizing of 3 variable functions. Let me have the function x0, x1, x2, 3 variable. So this is the SOP expression. In SOP expression we have the min-term as m1. I can represent it as in the form of 001. So 001, that is x2 bar, x1 bar and x0. So this is the form where I'll get the output for here is x2 bar, x1 bar and x0. Then plus I'm getting m2 I'm getting as 010 x2 bar, x1, x0 bar plus. So here all these product terms represented as a min term, and after this min term I am supposed to do the plus operation, that is what we called as I need to use the OR gate. So that's what all we are taken as 1 and min term 2, min term 4 and min term 5. So all the Boolean expression at last I supposed to do the OR gate. So here to implementing that SOP expression with active high outputs I am using the OR gate. So this is your SOP implementation. Similarly, one more example, 157. So I am taken as 1 and this is a 5 and 7. As usual, SOP expression, so that will be implemented by OR gate. Same way, for example, I want to be implement let's say some F3 function with the input of x2, x1 and x0, pi of max term of, let's say I can use that 2, 3, 4 and 5. How I can implement? So as we know that we can know that SOP is always complement of POS. So we have the equation as a POS expression. So I need to convert it into the SOP expression, so that I should take the complement of this form. So complement of this form in the sense I use the 2, 3, 4, 5. So I am using 2, 3, 4 and 5. So I am using the same OR gate, but I supposed to take the complement to get the POS expression. So I am using the complemented in the sense NOR gate. So this is your F3. So here it is a POS expression. The gate is NOR gate. This is how we can implement if you have the active high output with SOP expression as well as the POS expression by using OR and NOR gate respectively. So similarly, min term using NOR gate as we discussed. So here SOP complemented I am getting as a POS expression. So what I am getting as F1, X2, X0 I am taken as a 0, 1, 3, 4, 5, 6. So this is your SOP expression. So I supposed to take the complemented of this. So whichever the remaining min terms are, I am taken as a 2 and the 7. So this is the POS expression. This expression I can implement by using NOR gate. Similarly, I'll take the 1, 2, 3, 4, 6. So this is your SOP expression. Complement of this 0, 5 and 7 I can take. So connected to the NOR gate. So this will be I am getting as POS term, POS equation. Remember, as we know that we implemented for SOP using the OR gate. So implementing the POS expression I am using as NOR gate. So the next we going to be implementing the decoder by using the NAND gate. So here we will consider your decoder of having the active low output. So active low output in the sense I am getting the min term here So max term, here I'm getting the max term. It means that inversion of your min term. So I'm getting the max term. Similarly, so here is 0 0 0. It works with the z0 as a max term. For 0 1 it is z1, 2 3, like that I'm getting as a max term decoded output, that I can realize the expression for z0 is equal to, so z0 is in complemented form, so I can write it as a z0 bar, so that is a 0, I can write as x2 x1 x0 bar. So z0 is equal to x2, so this is x2 bar bar bar, x2 plus x1 plus x0. So this is what I am getting for a Poisson equation. So that is what here I am getting the max term of m0. Similarly, for decimal number for 0, z0 has decoded as a max term, 1 I am decoded as z1. So these are all your output as active low outputs. So now we will take the some of the equation to implementing that. So let me have the, so here I am getting as a max term. Max term in the sense I am getting as a sum term. So here I am using that product term. Product in the sense I can use that the word as dot. So you want to implementing some expression, so I can use the AND gate. So I'm getting the sum term here, all the terms as a max term. So I need to making as a product, so that is a SOP. So I am supposed to use the AND gate. So similarly, here the function is 0 2 6 7. So I'm taken as a 0 and 2 and 6 7. So for f1, so I can implement it as a complemented form, that is remaining one is 1 3 and 4 and 5, so that I can implement it complemented terms here. This is the SOP expression. SOP 1 I can implement by using remaining term as 1 3 4 5 by using AND gate. Similarly 3 5 6 7, so here I will take the remaining terms as 0 1 2 and 4 terms to be implementing f2. f2 is taken as 0 and 1 and 2 and 4 by using the AND gate. If you want to take the same term, you can use for NAND gate. So here if you want the let's say I'll take f3, let's say I can implementing pi of m of let me take it as 3 4 and 5. So let me take it as, here it is all the POS form, product of sum. So I can directly take the values as 3 and 4 and 5. So I'm getting here as a sum term. So then I want to use the product. So I use NAND gate to implementing this F3. So inverting of, because here we getting a inversion to this. So this is how we can implement the Boolean function by using your decoder. So one more we can use for decoder with the enable input. So why we using the enable? So here even if you are not given any input, it is 0 0, it is decoded as Z0. So always the output it is read by Z0 even if you are not given the input. So that's what I want to protect my device to be used for enabling the device. So this is the input I given as an active high. Whenever I make this as 1, then the device is enabled so that your output will be response to the corresponding input. So if you are given as 0, you can give any kind of input here. So your device is disabled. So then it will be, your output will be 0 only. That's what we are using the enable line. So when disabled, all outputs of the decoder can either be a logic 0 or logic 1. Enable input provides the decoder with additional flexibility. The idea is data is applied to the enable input. So that is process, whatever enabling process we call it as demultiplexing. So as we know that 2 to 4 decoder, it works with active high. This is 1. So Z0 is X0 bar, X1 bar, E. Z1 is that is 0 1, X0 0 1 in the sense this is 0. This is X1 bar, X0 into E. Z2 I can write it as 1 0, X1 X0 into E. Z3 X1 X0 into E. So this is the equation along with your enable inputs. Even here X0 is equal to 0, X1 is equal to 0, then data appear on the line is Z0 along with your enable. So enable input are useful when constructing larger decoder for smaller decoder. So here we can realize the 4:16 decoder by using 2 to 4 line decoder. So in the 4:16 in the sense, let me have the combination ABCD. So here the combination is like this: 0 0 0 0 and 0 0 1 1. This is one combination with the input, and the next we have this 0 1 0 0, and the same we can have 0 1 1 1. So this is one we can use one combination. This is another combination, and we'll take the 1 0 0 0. This will be taken as 1 0 1 1. This is another combination, and we have this 1 1 0 0 to 1 1 1 1. This is another combination. So 4 inputs. In this 4 input, the varies from 0 to 15. Now, so this I can realize by using 2:4 in the sense I supposed to take the 2 input for my decoder, so that I can differentiating this line. So whenever is CD as your input, so let's 1 2 to 4 decoder I can use, and this is 1 2 to 4 decoder, and this is 2 to 4 decoder, and another 2 to 4 decoder. So totally I can get it as how many outputs? 4 plus 4 plus 4 plus 4, 16 I am getting with the 2 inputs. But I again AB has also be there for selecting this. So whenever AB is 0, so this is your AB and this is your CD. So this is your D and C. So whenever it is 0 0, here this will be selected as 0 line, and this will be enabled. This 4:1 mux, first 4:1 mux will be working. This is the first one. And then next AB has 0 1, so this is 0 1, the second decoder is working, and 1 0, this is 1 0, third decoder has to be enabled, and this is your 1 1, fourth decoder has to be enabled. So like of the 4 input combinations, your 4:16 decoder has realized. Thank you very much.